This is the first lesson in our new geometry unit, and this lesson will be all about area. By the end of this lesson, you're going to be able to find the area of several shapes, including rectangles, other parallelograms, triangles, trapezoids, and circles. Hopefully, most of this lesson is a review for you. So the area is the number of unit squares that are needed to cover a figure, and we measure area in square units. So we want to make sure that whatever units we are using, we always have the little 2 or square by it. So the first one is area of a rectangle, and this should be a review. Please make sure that you're writing the formulas down, as you'll need to access these later. On iStep and standardized testing, formulas for any area volume that you need to know. So you don't need to memorize them, but you do need to have them down to access them for your worksheet. So the area of a rectangle is the product, which means multiplication of its length and its width. So the area of a rectangle is length times width. And we'll look at an example here. So you're simply going to multiply the length times the width. So area would equal 7.5 times 10. And if we multiply those two together, we get 75. And remember, we always need units, feet squared. So rectangle, we're not going to really review too much because, again, we've done this one earlier in the year. Now let's look at a parallelogram. First of all, it's important to understand that a parallelogram is essentially a rectangle that's kind of been shifted a little bit, so the angles inside aren't necessarily 90 degrees. But the area of a rectangle is the product of its base and its height. And you can see the picture on the left at the bottom. That's what a parallelogram looks like. And so the base is just the length of the bottom side, and the height is, again, how tall the parallelogram is. And if you see the little triangle that I've cut out there on the left figure, if you can cut that right triangle shaped piece from one side and you flip it back over to the other side, like I've done in the right, then you see that it actually forms a rectangle. So even though we don't technically call the sides lengths and widths, it's really almost the same formula as area of a rectangle, but we call them base and height. So let's look at an example for finding the area of a parallelogram. Here we have 6 2/3 centimeters and 3 1/3 centimeters for height. So again, area is base times height. So we're going to plug in 6 2/3 for the base, 3 1/3 for the height. Now, I don't want you to go reaching for your calculator right away just because we see fractions here. It would be very common to see a problem like this on iStep without the use of a calculator, but that's okay. We know how to multiply fractions. Remember, we want to candy cane both of these numbers. So it's going to be 6 times 3, which is 18 plus 2. So we get 20 over 3. And then 3 1/3, 3 times 3 plus 1 is 10 over 3. And now when you multiply across the top, you get 200 over 9. And then you can check to see if that can be reduced. You can change it back to a mixed number if you'd like. But it cannot be reduced, and so we just need to add our units, centimeters, and remember they're squared. So the area of that parallelogram would be 200 over 9 centimeters squared. The only thing you need to be careful about is if you were allowed to use a calculator and you were to divide that, you get 22.2 repeating. You would want to make sure to acknowledge that it's 0.2 repeating unless you're told to round. And now we have the area of a triangle. Again, we've done this one in the past. So we have area of a triangle is 1/2 of the base times the height. And remember, that idea of a half comes from the fact that a triangle is literally a half of a rectangle. So it's the same formula for area of a rectangle, but it's just cut in half. So let's look at an example. We have a base of 5.5. Remember, base is like the bottom. And we have a height, this dotted line in the center. This is not a side of the triangle. This is just letting you know what portion of the triangle is 3 inches in length. So area of a triangle is 1/2 times the base times the height. So we're going to take 1/2 times 5.5 times 3. And I will allow you access to a calculator for now. So we take 0.5 times 5.5 times 3, and that gives you 8.25. And remember that we want units squared, so inches squared. Oh, and I should state, it did say to round to the nearest tenth. So that's this place here. The 5 makes us round the 2 up to a 3. So that gives us 8.3 inches squared. Area of a trapezoid is one that's a little bit, one of the first ones that's a little complicated. Trapezoid has two opposite sides that are parallel, two opposite sides that are not parallel. So you can see that the left and the right side here are not parallel. But a trapezoid, to find the area, we take half of the height and then we multiply it by the sum of the two bases. So you can see here we have B1 and B2 labeled. The top and the bottom are the bases. So we're going to add that together, then multiply it by the height, and then either divide it by 2 or multiply it by a half. So here we have our trapezoid, and it's important, sometimes maybe you want to label, that's the base, and you can call it B1 or B2, and here's the other base, and then this is our height. So the area of a trapezoid is half of the height times the sum of the bases, and you're simply just going to plug the numbers in and crunch out an answer. So we get 1/2 times 4 times 10 plus 6. Then we simplify, and you can simplify a lot of different ways, but if we change the parentheses on the inside, we get 16. And now you're just multiplying across. 1/2 times 4 is 2. So 2 times 16 would be 32. And again, we want to make sure that we're squaring our units, 32 inches squared. So that's area of a trapezoid. Finally, area of a circle. And the area of a circle is found by multiplying pi and then the square of the circle's radius. Remember that a radius is the segment from the center of the circle to the outside edge of the circle. Some of you also remember that a radius is half of the diameter. So if we look at an example here, find the area of the circle, rounded to the nearest tenth. So area is pi r squared. And this is the first one where I'm not intentionally trying to trick you, but I want you to understand the parts of a circle. This, what's labeled here right now in the circle, because it goes from one end through the center to the other end, is the diameter. And I just mentioned in the last slide that the radius, which would be from the center to the outside edge, let's just do it right here on this part, the radius, half of that, so this would be 4 inches. So that's the number we need to use in our formula. We're going to use pi and then 4 squared. And when we get closer to I-step, we need to understand that we're no longer using 3.14 for pi. You're actually needing to use the pi button on a calculator. So what that means is that you're going to have a more precise answer because it's going to go out all of those digits. So in your calculator, you're no longer typing 3.14 times 4 squared. You're hitting the pi button, and then you're multiplying it times either 4 squared, or remember that 4 squared means 4 times 4, so that's 16. And it does tell us to round to the nearest tenth, but if we type in pi times 16, you get a very long answer, and I'll copy down what I have out to several decimal places here. But if we're rounding to the nearest tenth, that's the second or the first place after the decimal. So we look at the 6 behind it. It's 5 or greater. So that means we round the 2 up to a 3. And our unit again is inches. So we're going to say inches squared. So the area of the circle is 50.3 inches squared. So we were able to find the area of a rectangle, parallelogram, triangle, trapezoid, and circle. Again, make sure that you have all of the examples in your notes, including the formulas, so that as you work through the worksheet tomorrow, you'll be able to access those quickly. And in class, we'll work on the area worksheet.